In the binomial model, we're going to have this setup of Bernoulli trials. So binomial model will have this kind of specific setup for how we're going to calculate probabilities. Calculating the actual probabilities in the binomial model, we will do through GeoGebra, which I will show in the next video. A Bernoulli trial has 3 conditions that need to occur. The first condition is that each trial that occurs has only 2 possible outcomes, and we generally call those the success and the failure. Now, using success and failure, be careful of what's the positive versus negative. Success, you want to think more of matching up with what we are looking for if we're interested in having someone make free throws or getting a bullseye when shooting an arrow. Or even there could be an example where you're looking for microchips to fail. And even though that word failure is in there, if it's what we're looking for, that would be considered our success. So just be careful with those terms there. It's more about, is it what we're looking for or not what we're looking for? There should only be 2 possible outcomes. So we're going to have these trials that occur, and our notation is we use the letter little n for the number of trials that occur. So the experiment that we're running is limited in terms of how many times we run the experiment. The probability of success, which we use the letter P for probability of success, remains the same for each trial. So this probability of success does not change. So we use P for probability of success, and then we use Q for the probability of failure. And we'll have this relationship that since there's only 2 possible outcomes, they're complementary to each other. So if we have this probability of success, then that means that Q is just 1 minus that probability of success. So they should always add up to 1 together. Then we have that the trials are independent, and that the outcome of one trial has no influence on the next. So as we run these trials, this probability of success does not change. It remains the same. So let's look at this example and kind of talk about probabilities we've already talked about, and then what the binomial model is going to do for us. So we have this basketball player, and they make about 82% of their free throws. So in terms of, we're going to be looking for this basketball player making free throws. So this right here is our probability of success. So we have this 82% probability of success. And if that's our probability of success, you can find the probability of failure by taking 1 minus that 0.82, which is a 0.18. Assuming the shots are independent, so that's just kind of making concrete that we have independent trials. And what that lets us know is that each time she shoots, this probability of success is not changing. It's staying at 82% chance of making the free throw, 18% chance of not making it. And we want to find these various probabilities. So this first one says that we want to find the probability that she makes the first free throw on the 4th attempt. So what we're looking for here is the sequence of events, which we want to see her miss, and then miss, and then miss, and then on that 4th attempt, then she makes it. And the sequence of events, along with the fact that we have independence, this brings through our multiplication rule, that we're looking for these kind of and then scenarios, and with independence, we just multiply the probabilities. So it's the idea that we want failure times and then failure times and then failure and then success. So it's the idea that she misses her first 3 free throws and makes the 4th one. So this multiplication is we're going to have 0.18 multiplying with itself 3 times. So we can write that as 0.18 cubed. We can use an exponent to kind of shorten that multiplication, times that 0.82 for that probability of success. And when we calculate that, that would be a 0.0048. So there is a 0.48% chance she makes the first free throw on the 4th attempt. And very similar in this next question, what's the probability she makes the first free throw on the 12th attempt? This is where we'd want to see her fail 11 times in a row, and then she finally makes it on that 12th attempt. So this, we're going to have our probability of failure multiplying with itself 11 times, and then our probability of success. So we're going to have this 0.18 to the 11th power times 0.82. And this is about 0. This comes out to, so there's a 0% chance, or we should say there is close to a 0% chance, because it is possible. When you say there is 0% chance, it sounds like it's completely impossible, but it's just the probability is so low, it's basically 0. So there's close to a 0% chance she makes the first free throw on the 12th attempt. And the idea is it's almost impossible for her to do this because she's so good. She makes 82% of her free throws. So to mess up 11 times in a row and then finally make it, she's just too good to do that. With these two scenarios, the sequence of events is specific. It can only happen this one way. It requires failing 3 times in a row and then succeeding on that 4th try. And that's the only way that matches with this wording of make the first free throw on the 4th attempt. And same thing with the 12th attempt. She has to fail 11 times in a row and then have success on that last time. So with these two scenarios, the sequence of events is specific. With binomial model, this is where we can get less specific about how it occurs. So in part A, we looked at this, what's the probability she makes the first free throw on the 4th attempt? What if we just want to see the probability of her making 1 basket? What's the probability she makes 1 free throw out of 4 attempts? So with this, what if we wanted to know the probability she made exactly 1 basket in the first 4 attempts? And with this, the sequence isn't defined. It's not a specific way it has to occur. So with that, there becomes more possibilities. The idea being she shoots a ball 4 times. So this is going to be our number of trials. So there are these 4 trials. Her probability of success is this 82%. And her probability of failure is this 0.18. So what we could do is if she shoots 4 times, we can think about all the different possible ways that she could have this occur, having 4 attempts and making 1 basket. The idea being that she could make it on the first shot. She makes it on the first shot, that would look like having our success, and then she would miss the next 3. So having P times Q times Q times Q is showing she shot the ball 4 times for a free throw, she made the first one, and then missed the next 3. So this matches up with making exactly 1 basket in 4 attempts. Or she could have made it on the second shot, meaning she missed the first shot, then successfully made it on the second, and then missed the next 2. So this is the idea of 4 free throws and making it 1 time. Or another scenario could have been that she made it on the 3rd shot, which would look like her missing, and then making it, and then missing. So you'd have Q times P times Q. And then our last scenario is if she made it on the 4th shot, which would look like missing, and then missing, but then finally making it on the 4th try. So all of these show the idea of making 1 basket out of 4 attempts, and we kind of exhausted all of the possibilities for how that could occur. Now with using this word or, that brings through addition here, and it would be disjoint cases. There's no way for these cases to overlap with each other. So what we'd want to do for this probability is add them together. So this is what the binomial model is getting at. It wants to combine all of the possible ways a certain event can occur. But what we want to notice is for each of these events, the calculation's actually the same in that multiplication, you can move things around. So for each of these, like with the first shot, we have this failure 3 times and success 1 time. So it's that we'd have this 0.82 and then times 0.18 cubed. So we have our success once, and we could even write the exponent on that 0.82 as 1. So we have our success once, failure 3 times. and then plus, and we actually have the same scenario for the second shot. We have our success once and failure 3 times. And same thing for the next one. So we're actually adding the same probability to itself. What we just needed to see was how many different ways could it occur. But it's always this 0.82 times 0.18 cubed. And we have to add it to itself 4 times because of this scenario and how many ways that can occur. So we end up with is there's 4 different ways for this to occur. So we can do 4 times this 0.82 times 0.18 cubed. And that would calculate our probability for making exactly 1 basket in our first 4 attempts. And that probability would be a 0.0191. So there is a 1.91% chance she makes exactly 1 basket in her 4 attempts. So this worked nicely because it was a small grouping, but imagine if I was interested in what's the probability she makes 2 baskets in 30 attempts. And if I went through this list of all the different possible ways that it could occur, it would be a lot. It would be a lot to write out by hand. So this is where a small grouping using small numbers, not too bad, but what we want to do is use technology to make these calculations for us and then interpret them. But this is just to show how these binomial models are working, is that since it's not describing a specific sequence of events, it starts to think about, okay, what are all the different possible ways that event can occur? And it gives us this kind of multiplier to work with. So in this case, there are 4 different ways. And then it works with this idea of, but for all of the scenarios, we want 1 basket made, so 82% once, times, and if there are 4 attempts, then we need 3 failures there. In the book and other resources, you'll see the formula for this and for how to calculate it by hand. But what I'm going to do is rely on GeoGebra here. We're going to use technology to do the calculation for us, and that'll pop up in the next video.